Hello everyone, I'm Melvin Francis from BE.Services and I'm more than excited to be at the Coreflux Cracked event, and thank you so much for giving me this opportunity to present you all today at an amazing event. Hope you guys are having fun at the event. So a brief introduction about myself. I'm Melvin Francis. I'm located at Kempten, Allgäu, which is in the south of Bavaria, and we are like 90 minutes from Munich. So to talk about myself, I am 10 years experienced in industrial automation, and I started my career with as a developer for a protocol named Open PowerLink, and since then I've been working with different industrial Ethernet protocols like Profinet, EtherCAT, and so on. And I slowly moved my transition to the modern protocols like OPC UA and MQTT. And currently I am holding the role as technical marketing manager for BE.Services, where I am doing the technical marketing related to the products and services that we offer here. So today I'm here to present Edge AI Intelligence Pipeline, where we are going to take MQTT data from a factory floor and we are going to push it to a broker, the edge broker from Coreflux, and from there we are going to use Coligo, which is an edge AI solution where it monitors the MQTT data and provides you back the inference back to the factory floor, which will make sure that you can take some informed decisions from the inferences provided by the edge AI software. So if I say to use ChatGPT, you should be an AI expert, that would be quite a stupid statement, right? So similarly, for factory floor AI intelligence, you need not know AI to use the edge AI related software. So Coligo has this ideology where we do not require any kind of AI background to use edge AI, and where it is as simple as that. If you have any kind of MQTT data available on your factory floor, it is very simple to monitor it, and you can run an AI model where you can train everything at the edge. So the data is not moved to the cloud, but everything happens at the edge, and also you can train the model. And once the model is trained, you know that when an unfortunate situation happens, there is an immediate inference sent back to the factory floor where you can take some informed decisions based on the AI inferences provided by Coligo. So Coligo is a kind of an edge AI platform for automation engineers where there is no code involved. It is just within few clicks you will be able to create the entire pipeline. So Coligo itself cannot work by itself, so that's why we need an edge broker, and we will see how you can use the edge broker intelligence and to create your entire factory floor pipeline from the scratch till creating an entire pipeline of intelligence we are going to see. So most of the MQTT data right now in the market, you will find out solutions that you can monitor them, you can also control them, but to involve AI, you need to do a lot of things. So that is cumbersome, and to make it simple, today I'm going to present you a step-by-step approach about if you have MQTT data, how you can make it more intelligent and take some informed decisions based on AI inference. So it isn't cool, and the most attractive part is that everything that we are going to do today will be presented to you as a guide where you can repeat the entire system that I have explained it today on your PC within 1 hour of time. So that is a promise that I give you, and it is going to be very, very simple. And let's take it step by step, and let's hop on to the demonstration immediately. To hop on to the demo, what we are going to see today is a factory floor example where I have created this sample with Node-RED so that it is easy for anybody who's watching this video to repeat it by yourself, and it is very, very easy. So I've created this factory floor example where there are process 1, 2, 3, 4 and 5. There are 5 processes that are available, and all the process related information for each of these machines available is sent to the broker, and from the broker the Coligo AI will be monitoring the data, and we will be training the model based on what is the process that is happening here. And once the model is trained and there is no new data to be learned, what Coligo does is it changes from the learning mode to the inference mode. And once you have the inference mode, the Coligo Edge AI software returns back the AI inference in a specific topic, which can be also monitored back on your factory floor, and you can start taking informed decisions based on it. And also, if your broker is going to have some intelligence, you can also use some concepts like language of things, where you can say that once there is an anomaly is detected, you can also using unified namespace concepts, you can send out an information, for example, an emergency stop to the entire factory floor where all the processes stop instantly. So it is very, very simple. So the demonstration that we are going to show here is with Node-RED. We have created a factory floor example, and with the process of each of these 5 machines will be sent to the broker, and the Coligo Edge AI software will be listening to these information, and it does learning. And once the learning is done, it goes to the inference mode, and once the inference is done, it sends back an anomaly score, and based on the anomaly score, you could take some informed decisions. So let's hop on to the demo instantly. So now let's hop on to the Node-RED sample that I have created for this particular application. So this is the entire SCADA code, that kind of an application that I have created. So you will get this entire project, and I will also let you know step by step like how to configure it, how to repeat it, and how it is all done. So now let us see what is happening in this example here. So let me shrink my video and let's see what happens here. Right now you can see that if I click all machines to run, so you can see that the working time is incrementing step by step, and then there are pallet boxes that are being incremented step by step. So now all the processes are working in an efficiency like 90% based on of each of their process. So this is just an example, not think like this is exact replica of the factory floor. You can also tweak these values to make a more realistic kind of a demonstration. To have keeping time in mind, I have created this application to explain everything so that it happens instantly and we can show the entire pipeline that happens here. So this is the Node-RED example that I showed you in the previous slide. So the factory floor is what you're seeing here. So inside the factory floor, there are, as I told you, there is process 1, 2, 3, 4, and 5. So what happens is all of these processes send their information to the broker, and the broker is having all these information right now. So now this is done already, and we can see that the broker is able to get all the information, and I have deployed the broker using lot notebooks. Within just few clicks, you can see that the local host is connected and all the processes are being monitored here. And so now the next step is to configure Coligo to absorb all these information. So let us see how it is done. So now let me open the Coligo UI and let me enter the default password, and let's get into the Coligo UI. So Coligo Lite is a version for MQTT based AI intelligence. So now let me configure the anomaly detection model. So let me go into the anomaly detection model, and I'm going to create a new model for this particular use case. So as you know, let me say it is CF Cracked event, and let me create this model. Let me go to next, and I'm going to connect to the edge broker that I have configured already, and I'm going to put the topics to monitor all the process. So with plus, all the processes will be monitored, and let me enter the password to get into the broker, and let me go next and enable TLS and monitor the data of this one. So it is just a raw data that I'm going to send. So the path is very simple. So now let me create the path. Now the model has been created. Now that I've created the model, we can see that you have the learn and the infer options here. So now let me quickly go to the dashboard. Now all the systems are running. Now you can see that there is no anomaly score increasing or decreasing. That is because we have not yet configured the model. So all the machines are running. So now let me monitor all of these processes, and let me click on learn now. So when I click on learn, what is happening is whatever is, so let me keep the screen side by side for an easy visualization. So what happens right now, all the process of these machines are being learned by Coligo here. So you can see that the training loss is going close to zero because it is already learning all the information that is provided by the machines, and it is slowly going down to zero, and soon you can see that the value will be reducing drastically low. So right now you can see that the anomaly score is not increasing. That is because I have not yet linked with the right topic. So for us to get back the anomaly, so just like we saw it inside the diagram here, for Coligo to send back the data, you need to specify the right topic that it needs to proceed. So for us to get the right topic, what we need to do is inside Coligo, we need to mention the right topic name here. So I have configured it to be Coligo Lite /Coligo/Lite/Anomaly to do this demonstration. Let me save this, and you can see that once it changes to the inference mode, the anomaly score will be increasing. So let's wait for some time to see what is happening once the process is learned completely. So you can see initially it got a lot of new data, slowly it goes down, and now it is at 0.2 or 0.1 where there is no new data to be learned. So let us wait for a few seconds. So this is what I'm trying to say is like it is a no-code AI model. So all the MQTT data that is available in your factory floor can be monitored. So there is a statistics that almost more than 90% of your factory floor data goes unused. So having data is one level, but without processing it, there is no use of you monitoring your data. So with monitoring, you can create nice dashboards, but to take some informed decisions, this is where you would need a AI in kind of an intelligence for us to say that this is how it is. This data is now acting normal, but now it is acting abnormally, and you are able to see an anomaly. So now we can see that the anomaly score has gone almost close to zero. So now let me stop the learning, and now this is the normal way of the machine performing. So let me stop it and let me go to the inference mode. So in the inference mode, you can see that the score is very less. So that's why the anomaly score is not increasing here, because I've mapped it to 0 to 50. So let me blow up the screen here, and you can see that the machines are running fine now. To explain this demonstration in an easy way, so what I'm going to do now is, so I'm going to introduce an anomaly kind of event here. By clicking this button, I create an anomaly event, and you can see that the anomaly score is bumped up instantly. So even in the graph from Coligo, you can see that all the values are bumping. So you can see that already an anomaly has been detected. You get an information. So all this information is also being sent back this particular topic, and this topic is monitored in the anomaly score that you are seeing here. So the anomaly has skyrocketed now. So soon, using our Coreflux LOT functionalities, which I have already programmed it here, you can see that it will instantly switch off all the machines instantly. So let me go now, and you can see that all the machines have stopped running now. So you can see that all the machines have stopped running, and there is no movement here, and they are back to their normal kind of a procedure here. So you can see that the working time has stopped, and the machines have been saved from a drastic catastrophe that is happening here. So this is a typical use case in your factory floor, where suddenly if you see a spike inside your system, you cannot save it until you understand your existing data. And if you understand your existing data, then you need not have complex if-else statement. So right now we had an example with 5 machines here. So imagine if your factory floor is going to have like hundreds of machines. So can you write an if-else statement or bracket statements for all of them? It becomes a cumbersome process. So even if one machine changes, then the entire anomaly events happen continuously. So this is where the AI comes into picture. So now you can see that the machines have turned back to their original working state, and slowly the anomaly score will get down. in few instances. So right now it says that you can see that the drop has started to happen in some time once all the machines turn back to their original working state. So now they are turned back to their original working state where the switch has happened instantly, and you can see that the anomaly score will soon go down step by step. So this is a typical example that I would like to show here, which I'm showcasing here, but this cannot be directly mapped to your end devices or your factory floor kind of an application. So this is because I'm pushing the timeline, I'm increasing the anomaly event score to a high level so that I'm able to demonstrate it quickly here. But in your regular factory floor, let me take an example of, imagine you are in a logistics of, and imagine that you are monitoring your humidity. So humidity will not drop instantly, but if you monitor it over days of time, you will know that the humidity on a regular flow is not the same, but today the humidity has suddenly gave a spike which takes like multiple hours to change. So once this particular humidity is found by your AI model, then your AI model will tell to your factory floor to say that, hey, something wrong is happening. So this is what I'm trying to demonstrate here, and this becomes a typical use case about how we could use your edge AI intelligence, and you can create a lot of use cases around it. So getting back to the original diagram here, so we have seen like what is happening here is the factory floor sends its data continuously to the edge broker, and the edge broker, the data from the edge broker is being monitored inside Coligo, and from Coligo the edge AI inference is sent back, and using lot functionality we are not stopping the machines one by one, but we send all the stop data to all the machines using unified namespace. For example, if you use the plus symbol, then you can say that all the processes can be a wildcard entry can be done, and all the processes can be stopped instantly, and it can also send messages to your factory manager to say that, hey, something is going wrong, and then he hits a reset button, then everybody goes back to the normal operation. So this is a typical example, and can be also used for temperature monitoring or your process monitoring. So even on a palletizing robot, so imagine that you have a robot application that does a regular process. In case if the robot is not operating properly, you can monitor the torque value of the robot, and the robot, if in case there is imagine if it picks up a palletizing box that is empty, then the torque becomes abnormal, and the Coligo AI model will be able to say that, hey, this torque is not good, and it can immediately make a alert back to the broker, and using the intelligence in your broker, you can make sure that to stop the entire factory line and stop a huge catastrophic accident that is happening. So the possibilities are endless. I think I gave like few use cases. So here we are monitoring the process efficiency. I also gave an example about temperature monitoring, humidity monitoring, and torque monitoring. And I guess this example would help you to take this particular application and put it into your factory floor and try to monitor and make more realistic use cases beyond this demonstration. So to repeat this entire setup, I will be providing a PDF which will give you step-by-step actions to repeat this entire mechanism, that your entire pipeline mechanism that you're seeing here. And instead of this particular factory floor, you could replace it with your own MQTT data that is already available in your factory floor, and you can get this working right away. So with this, I'm ending my demonstration of AI. So any questions, I will be more than happy to answer. You can find me on LinkedIn. Melvin Francis is my account, and you can get in touch with me and we can discuss more, and I can also help you to get your AI intelligence done instantly, and we will be assisting you from your start till the end and in your integration journey as well. So I take this opportunity to thank everyone for having me here, and I'm more than proud to get this slot. And although I'm not able to be on site, I got this opportunity to present this in an online way, and I'm more than thankful to have this presentation slot, and hope you have fun the rest of the day. There are exciting presentations, and I am looking forward to interact with each one of you after this presentation. And please share your feedback. And thanks again to everyone from the Coreflux team for providing me with this opportunity. So have a nice day ahead. Thank you.